Guys, welcome back to the LearnAPCalc series here at LearnAP. In this video we're going to go over the basics of antiderivatives. So we're going to talk about what is an antiderivative, techniques to find them, going over the reverse power rule, substitution, rubber banding, and long division. We'll go over integrals you need to know, and then application of this, separable differential equations. As usual, if you guys have a question about this, you can ask in the comments below, or in our weekly live streams we do every Sunday from 4 to 5 p.m. Eastern. Alright, so other than that, we'll get started. Alright, so let's talk about what is an antiderivative. An antiderivative is where you take a function and you modify it so that if you took a derivative of the modified function, you would end up with the original function. So that's sort of wordy, so let's take for example y equals x squared. The antiderivative of this is we're going to modify this so that if we took its derivative we would get x squared. So knowing the power rule, I'll try x cubed. So if we take the derivative of this we get 3x squared. Pretty close, but not quite. But if I do x cubed over 3, now I do the power rule, I get x squared when I take the derivative. So therefore, x cubed over 3 is the antiderivative of y equals x squared, because when I take the derivative of this, I get this. And now note that the antiderivative of f of x is written like so. And this is called integration. And so this is the integral symbol, and dx just simply represents what we're integrating. So if I wanted to write the antiderivative of y equals x squared, I would write it like so. And this simply means take the antiderivative of x squared with respect to x. Alright, so you might be wondering, well, how do we find an antiderivative? And the first is the reverse power rule. So if we have the antiderivative, or also known as the integral, of x to the a, this is going to be equal to the power plus 1, x to the power plus 1, all over the power plus 1, plus c. So you might be wondering, well, what is c? Well, c is a constant that can be anything. And to show you why that's there, let's take the derivative of this. We're going to get a plus 1 times x to the a over a plus 1. These are going to cancel, and then the derivative of a constant is 0. So this just equals x to the a. And so that's the point of plus c, is that when we take an antiderivative, we always add some arbitrary constant c that can be anything, because when we take this derivative, c is going to go away. And so that's something very important to note. When you take an integral, these are called an indefinite integral of anything. Let's say of f of x, and we get some function big F of x, you always have to add an arbitrary constant. And so this is a thing a lot of people forget about, and it's a very common mistake to make. So remember, whenever you take an antiderivative or an integral, always add plus c. Alright, so one method I just discussed is the reverse power rule, which is very useful. But what if you have something like this? That's not necessarily the easiest thing to know right away how to integrate. And so what you can do is what's called rubber banding. And this is the technical term. And what we do is we sort of divide this out like so. And so we rewrite this as this divided by this. So it's just going to be 5x. And then here, 6x cubed. And now we can take an integral. So we're writing our fraction as multiple terms, and then we're integrating. And this technique is very useful, but it only really works if the denominator is one term. And so if you're wondering how I did that, consider the example of 5 minus 6 all over 7. This is equal to this. And that's essentially what we're doing when we rubber band. 5 over 7 right here, 6 over 7 right here. And what this does is it sort of negates the fraction and gives us something we can integrate. Alright, so let's talk about perhaps the most useful method of integration, and this is Usubstitution. And so take, for example, this integral right here. I can't do the reverse power rule, and it's sort of hard to think about what would be the antiderivative here. And so what we do is what's called Usubstitution. We're going to set u equal to some term inside here. So for me, we'll say u equals sine squared x, so this term. And now we're going to substitute that in. So integral of this times e to the u, because remember u equals sine squared x, dx. Now it's apparent we have a problem. We're trying to integrate with regards to x, but we have a u. So we need to integrate in terms of du. So how we do that is we take a derivative of this, saying that du equals then the derivative of sine squared x, which is 2 sine x cosine x dx. And now I'll solve for dx. Okay. And now I can substitute this in here. And so subbing that in, we can see that our terms are going to cancel out. So I'm plugging in this equation here in for dx, and this is going to cancel out. And so we're left with the integral of e to the u over 2 du. Now, a great thing about integrals is you can pull out constants. So this is equal to this. And the integral of e to the u, du is just e to the u. So this becomes e to the u over 2 plus c. And then once you're done, once you've got your answer, you need to substitute backwards. So u equals sine x squared. So e to the sine squared x, over 2 plus c. Okay, so that's how we're doing it. We're sort of setting u equal to one of the terms. We substitute in, and we substitute our dx in for du, and then we do the integral. Now note that in this example I knew right away which u I was supposed to substitute in for, but a lot of times you're going to have to sort of guess different u's to find the right one to substitute for. Because again, when we do this integral here, we only can have u. If we have x in there, we cannot integrate, so you have to pick the right u. Alright, so another method to use is polynomial long division. So taking this integral up here, and that should just be x plus 1, sorry about that. It's not apparently clear how we're going to integrate this. But if I divided out this x plus 1 from this polynomial, I can get something that I can integrate. And so what I would do is polynomial long division, take the result, and then integrate it. Now here I can do a little shortcut, and this is something that you should be familiar with. This is called synthetic division. And this only works if our x here is to the power of 1. If we had x squared, we'd have to do sort of normal polynomial long division, which is this. But here I'll show you the shortcut. So what you do is, first we're going to write this little box here, and then I'm going to write out the coefficients of each of these terms. So 1, -9, -10. And I'll draw a line here. Now in this box is, right here, is the opposite of this term, so -1. Now what I do is I pull my first number down, 1, multiply it by this, what's in the top box, so -1, add these two together, -10, times -1 is 10, adding together 0. And so now these are the coefficients of my next terms. So x minus 10 is the result of my polynomial long division using the shortcut of synthetic division. Alright, so this is basically just the integral of x minus 10 dx, which is x squared over 2 minus 10x plus c. So if you have something like this, what you're going to want to do is polynomial long division. If you can, you should do this synthetic method that I just showed you, but otherwise you can do sort of the long way, which would look like this. Alright. Okay, so now let's talk about some integrals you need to know. And the first one is that the integral of 1 over x dx is ln absolute value of x plus c. And this absolute value is here because in this 1 over x we can have like x equals -1. But if this were just ln of x, my -1 would not exist in this domain. So we put the absolute value there. Alright, and just some other general ones. I won't walk you through any of them because they're all pretty obvious. I'll sort of zoom out so you can take a screenshot if you need to. Okay, and one thing I would say is this one does come up quite a bit. So be sure to know that if you see this, that you don't need to do polynomial long division or some other method, that this is literally just arctan. So good one to know, to recognize. Alright, so that brings me to today's challenge problem. Find the integral of x plus 3 times a quantity x minus 1 to the 5th. Now, do not multiply out. 1, it'll save you time, and 2, that sort of ruins the purpose of we're trying to get you to practice techniques of integration. So don't multiply this out. As usual, the solution is on our website, learn-AP.com, and I'll also put the direct link in the description. If you guys enjoyed this video, please leave a like and be sure to subscribe for future content. Like us on Facebook and follow us on Twitter for updates about new videos and new content coming out. A link to that stuff will also be in the description. Leave a comment if you're still confused about any of this stuff that I went over, or also any other comments on the video in general. Other than that, I want to thank you guys for watching, and I will see you in the next video.